Working on solving systems of equations algebraically. And we start off with a method called substitution. Now, eventually we'll go to elimination as another one of the tools to solve a system. Elimination by addition and subtraction, and then multiplication and division. But that comes up a little later. Now, we've got a system here. We've got two equations and two variables. Y equals 4x minus 6. And 5x plus 3y equals -1. And we're trying to determine, is there a solution to this system? And we know that there's either going to be one solution, one exact solution, where the two lines are going to intersect, two linear functions will intersect, or there could be infinitely many solutions where there's the same line, or lastly, it could be that we have no solution. But when we're talking about, in this setup here, let me say this. This first equation says just y equals 4x minus 6. And so therefore, I can substitute the 4x minus 6 in for y into the second equation and solve for x. And then once I get a value for x, I can go back to one of the two equations and substitute that in for x. And then obviously solve for y. So let's begin with that. So if I'm going to substitute the 4x minus 6 in for y into the second equation, then that would be 5x plus 3 times 4x minus 6 equals -1. And so then here algebraically, I want to distribute the 3 to the 4x minus 6, so I got 5x plus 3 times x is 3x, and 3 times -6 is -18, watch your signs, equals -1. Well, I can combine that's not 3x, that's 3 times 4x, I'm sorry, 12x. All right, so I can combine the 5x and the 12x, and then we'll have 17x minus 18 equals -1. And then we can add 18 to both sides. And so -1 plus 18 is going to be 17. And then we got 17x equals 17. And of course, dividing both sides by 17, we're going to say that x is equal to 1. All right, so now that I've got a value for x equals 1, I can substitute that 1 in for x into either of the two equations. Well, let's just do the top one. So then it would be y equals 4 times 1 minus 6. And of course, 4 times 1 is 4. Minus 6, 4 minus 6, y is equal to -2. And so now we've got a solution, we think, where x is 1 and y is -2. Now, particularly if you're testing, you want to check your solution. And so I'm going to take the second equation here, and I'm going to substitute in 1 for x and -2 for y, and see if that's going to equal -1. So let's go about that. So I've got 5 times 1 plus 3 times -2, and we're hoping that's going to equal -1. Well, 5 times 1 is 5, and 3 times -2 is -6. And 5 minus 6 is in fact -1, and so -1 does equal -1. And so that is a true solution. And if I wanted to be extra careful, I could even substitute it in for the first equation. So how about that? Let's substitute -2 for y. And let's set that equal to 4 times 1 minus 6. And -2 equals 4 times 1 is 4 minus 6. And -2 does in fact equal -2. And so my solution, 1, -2, proves true in both equations, and that is the solution of a system by substitution. Let's see, I think we got one other to look at. Well, here's our second system that we have. So we've got 2x plus 5y equals -1. And then we've got y equals 3x plus 10. So again, this is a perfect setup to use substitution, because in this second equation, I've got y isolated by itself, and I can substitute that 3x plus 10 in for y in the first equation and solve for x. So let's go. We got 2x plus 5 times 3x plus 10 equals -1. Well, let's distribute the 5 to the 3x plus 10. So now we got 2x plus 15x plus 50 equals -1. And well, we can combine the two like terms. 2x and 15x is 17x. They like 17 in this, don't we? And then we can subtract 50 from both sides. And so -1 minus 50 is going to equal -51. And then divide both sides by 17, isolating the x, where x is equal to, let's see, -51 divided by 17. I think it's going to go in there 3 times. Or -3. 3 times 7 is 21. 1 carry the 2. 3 times 1 is 3 plus the 2, 5. Okay, good. So it's -3. X is equal to -3. And now let's plug in the -3 into either equation. Doesn't matter which one. I'm going to use the second one because I just used the first one. That's the only reason why. And solve for y. So we got y equals 3 times -3 plus 10. Okay, well, 3 times -3 equals -9 plus 10. And -9 plus 10 is 1, so y is equal to 1. And so we believe our solution then is x is -3, y is 1. Let's test this back into the first equation, substituting in -3 for x and 1 for y. How about that? 2 times -3 plus 5 times 1. We're going to see if that equals -1. 2 times -3 is -6. 5 times 1 is 5. And -6 plus 5 is -1. And -1 is, in fact, -1. And I could put that in to the second equation and solve it. But, hey, I've checked it. I feel pretty good about it. And the video is running a little bit long. So there we go. Solving systems of equations by substitution.